approximately 2 millimeters high. And again, this is the standard setting for most of the elements done with acetylene flame. Prior to going into our calibration screen, it is a good idea to check the energy of our standards by going into the blank and pressing Auto Zero, just to zero out any particular background that we may have, and then going into the high standard and making sure you get some absorbance reading. This is particularly useful and avoids wasted time for elements such as iron, nickel, cobalt, and manganese that have many wavelengths when dialing in the alignment screen, but only a few of them are actual absorbing wavelengths. In this case for copper, we see we have plenty of energy, so now we may go back into the blank and go into the calibration mode by pressing the Cal key, and here we have a blank calibration table. The default setup is a blank and 2 calibration standards. To take advantage of this, we will go into the control screen, set our units to whatever is suitable, in this case parts per million or ppm, and press the Enter key to lock in that change. We also have the capability to utilize a second order calibration curve, which will take advantage of the 2 calibration standards. Again, make that change using the left-right arrows and then lock it in with the Enter key. Press Escape to go back to the calibration table. With a new calibration, one of the things that must be entered is the concentration value. So press the Select key on the keyboard and scroll the cursor over to the second column, which is concentration. It is good laboratory practice to go from low to high concentration. That is why the blank is first. And in this case, we're using a 1 ppm copper standard. So we enter in 1.0 and press the Enter key. Using the down arrow, go down to the second standard, which is 5 ppm. We enter in 5.0 and press Enter. Use the Select key to scroll back to the cup number column, and we can have the system automatically tell us how to calibrate by pressing the Start key. This prompts us to aspirate our blank, which we're already in, and press the Enter key. The system will take a timed integration, typically 3 to 5 seconds depending upon the element, and put the absorbance value of 0, in this case, in the absorbance column. The software now prompts us to go to our second standard, which is the 1 ppm low standard. Wait a few seconds for the solution to equilibrate in the flame and press the Read key. The default allows us to take 2 readings of the standard, and the software will automatically average these values and put the average value in your concentration absorbance column. We now go into our high standard, which is the 5 ppm, and again press the Read key to take our 2 readings. And now we have our completed calibration table. To see our calibration curve, we press the Cal key, Yes to accept the values, and Enter to plot them out. And here we can see a very satisfactory calibration curve with our blank, our 1 ppm, and our 5 ppm standards. At this point, we go back into our blank cup to avoid wasting the standards. Press the Escape key 2 or 3 times to return to the active analysis screen, where now we have parts per million as our units instead of absorbance. And at this point, we could aspirate our standards or samples and do our analysis. If you're doing many samples, in excess of 8 or 10, you can automatically recalibrate from the active analysis screen by using the Auto Zero and Reslope functions. To do this, while aspirating the blank, press the Auto Zero key. This will automatically reset our 0 point for the curve, and then aspirate your highest standard, which in this case is our 5 ppm standard. Wait a few seconds for it to equilibrate, and then press the Reslope key. This will automatically reassign the absorbance of that to 5 parts per million. In flame AA work, a variability of 3 to 5% is typical. At the end of our analyses, go into the blank or some dilute acid rinsing solution and allow any salts or residual samples or standards to be flushed from the burner head and the spray chamber. Remove the Teflon line from the sample rinse cup. Let the burner head run dry for a few seconds and then press the red off key to automatically and safely extinguish the flame. At this point, we can either change our element for air acetylene work or change our burner head to begin to do nitrous oxide acetylene work. Based on a satisfactory calibration, samples can be read by aspirating the sample, waiting a few seconds for the aerosol to equilibrate in the burner head, and then pressing the read key. Depending upon the setup options for the output, the software will automatically calculate statistical values for you, such as average, standard deviation, and relative standard deviation. Please refer to the Buck Scientific 211 manual and mini guide for details of this. Certain refractory elements of the periodic table, such as titanium, vanadium, molybdenum, barium, require the higher temperature of a nitrous oxide acetylene flame to achieve suitable absorbance signals. This procedure demonstrates the steps taken to change the burner head, make sure the safety interlocks are connected, then check the gas flows and automatically switch over from air acetylene to nitrous oxide acetylene. To change the burner head, shut the power off to the 211 using the power switch on the right side of the instrument. And then using the enclosed hex wrench, loosen the cap nuts that secure the burner head to the spray chamber block. If the burner head is hot, use the handle to lift the burner head off the burner head spray chamber and put aside. Please note that there is an O-ring assembly inside the opening of the spray chamber. Periodically, it is a good idea to check the integrity of that O-ring and replace it with a spare included in your installation kit. The nitrous oxide burner will have a collar that will also connect to the spray chamber, and as you can see, when it's properly inserted, the round collar should lay flat against that O-ring. Use the hex wrench to tighten down on the collar to secure it to the spray chamber head. Once the 3 cap nuts have been secured, you will find a little braided cable with a safety plug on the end. This is inserted into the appropriate socket on the left side of the burner chamber. At that point, you can see the green nitrous oxide inner light lock go off, showing us that we're prepared to run a nitrous oxide flame. It is good practice because of the ionization effects and the very high temperature of the nitrous oxide to prepare all your samples and standards with a lithium buffer or potassium buffer to minimize ionization losses. The procedures for this are fully documented in the 211 AA manual, the mini guide, and the textbook recommended by Buck Scientific by Bernard Wells. We will do some analysis of barium for our nitrous oxide demonstration, and the barium lamp is inserted in lamp 2. So again, by pressing the library key, the select key to select lamp 2, and then the up-down arrows to select the barium absorption line. You press 2 and enter to load that file into the lamp 2 position, and then press the escape key following the directions that we did before, setting the slit and wavelength so that we may maximize the energy of the hollow cathode lamp. There are some elements that do not utilize the deuterium background correction system because their wavelengths are above the recommended UV region of 440 nanometers. Barium at 554 nanometers is one of these elements, and this way you will only get a single bar graph line and a single energy value for the hollow cathode lamp itself. Once this has been optimized, press the Auto Zero key to return to your active analysis screen, and then using the buffered solutions, we will want to make some optimizations of both the fuel flow and the burner position, which are more critical in nitrous oxide operation than in air acetylene operation. Unlike the air acetylene flame ignition, we want to set the air and acetylene at the same flow rate. So press and hold the air button and adjust the fuel flow so that the ball is at the same level as the air and acetylene. Press and hold the green on button, and you can see the air acetylene flame will light. The nitrous oxide burner head is a much more dynamic flame and requires very specific gas flows to ensure safe operation. The 211 will allow you to change over to nitrous oxide automatically once the air acetylene flame is lit by pressing the N2O or nitrous oxide button, which will automatically increase the fuel flow to make a very rich flame, and then change over to nitrous oxide, as we will now see. This rich flame with the soot forming at the tip is normal, and then you have a very safe changeover to nitrous oxide, and at this point we use the fuel adjustment knob to reduce the acetylene flow so that we have approximately a 1-inch red feather or red zone going over the burner head. We will fine-tune this with our sample and standards and by aspirating our blank. Press Auto Zero if necessary, and then we aspirate our high standard. In this case, this is a 20 part per million barium buffered with 1,000 parts per million lithium. And we adjust our burner head height primarily, and then the horizontal position, till we get our maximum absorbance signal. Go slowly as the adjustments require some time to allow the light energy to pass through the flame. Different elements will require different degrees of optimization. So for nitrous oxide work, this is a standard protocol. Sometimes it is necessary to also adjust the fuel even lower or higher as needed to increase our signal. And here we can see we're averaging a 0.1 absorbance for a 20 part per million buffered barium standard, which is excellent. As with our air acetylene operation, we can now go into our calibration screen, go into our blank. In this case, the previous operation had a blank and 4 standards. To eliminate a standard, just enter 000 and enter for the cup number position. And for the case of barium, we're going to do a single point standard, so we move the cursor arrow up, enter 000, eliminate that standard, and then as before, we can enter our concentration value. To add standard cups, just enter in a cup number in sequential order, and you could add as many standards as necessary to achieve a good calibration curve. Scroll up to our low standard, enter in 20.0 in the case of barium, enter. Press the controls key. Make sure we're set for part per million. in the unit, press enter, and in this case with a single stem,